Welcome, folks. For this last practicum, we're going to do a qualitative analysis that is going to separate out three different metal cations: iron, nickel, aluminum, and chromium, through various methods. So, while I'm going to do this video for you right now, we're also going to do it alongside me coming soon, and this will be the positive test for all the cations. What you will eventually be expected to do on your own is to recreate an actual test and test for the presence of 1 to 2 of those metal cations. You will not have all 4. So you'll be looking for positive confirmation for what metals you have. But on this trial, we will see all 4 being present. So as we'll see here, this contains all chromium, iron, aluminum, and nickel. I'm going to look at each individual one over here. See, chromium is blackish, purplish blue. Aluminum is more or less colorless. Nickel is kind of a bluish green, and iron, when it's not fully oxidized, so this is the, you can see particulates, is very orangish. As we are working with a different concentration for some things, we'll modify accordingly. First thing I gotta do is to pour this into our beaker. Now, technically, yes, I'm supposed to be using something like a 30 ml beaker. I don't think I have that small, so I'll use a 60 ml beaker, a 50 ml beaker. Next step, need to add about 2 mils of 6 molar base. Now, because I only have 4 molar base ready, I'm going to use a little bit more than 2 mils. Let's see, maybe about go for 3 mils. This right there is 2 mils. A little bit more. So about 3 mils of base, and I've got to boil this solution gently for about 1 minute. So I'm going to turn on the Bunsen burner. And I'm going to carefully, with my tongs, boil this for about 1 minute. Note, I do not want to boil it to dryness. If I boil this to dryness, I will need to redo it. Oh, sorry, it's starting to splatter, so I need to maybe reduce the heat. Remember, to reduce the heat, I can twist that either up or down accordingly, so that not as intense of a flame. Oh, it's starting to explode. Need to clearly be a little bit more careful. Oh, maybe I should even use a bigger beaker. But you can see the solution is starting to darken. And that is a solid precipitate forming. The minute is only a really approximation. I'll need this again in a little bit of time, so I'm going to put this back down. Now, because this is hot, I don't want to burn my little, I'm going to put it on the Teflon. So, with that in mind, the next step is to add sodium hypochlorite, essentially bleach. So I'm going to remove it from the flame and slowly add 2 mils of this. And I'm going to gently boil this for now another minute. This, I do have the right concentration, so I'm going to slow. That's about 1 mil, and I'm going to go back for another mil. So, slowly, carefully add about that aside. Carefully boil this for another minute. Trying to heat it, but maybe not heat it so directly so that it doesn't boil, splatter, and get the chemicals where I don't want them to be. But the heat basically speeds up whatever reaction I have. Boil gently so. Try not to overly heat it. Once again, a lot of these things are approximations. So if I heat for a little bit more than a minute or a little bit less than a minute, it will not hurt. I think that's probably not a minute, but that's probably close enough. The next step is to add about 16 drops of 6 molar ammonium hydroxide. Now, because I have half that concentration, I am going to add twice that amount. So, 32 drops. 1, 4, 5, 6, 7, 8. 15. That's first 16. 3, 4, 5, 8, 9, 11, 12, 13, 14. A little bit extra will not hurt. This solution should be thoroughly basic at this point. I probably forgot to do this, but you should swirl for about 30 seconds before we heat it for about another minute. I forgot to do that with the sodium hypochlorite. Trying to make sure it's fully mixing, fully reacting. One more time, heating. Oop. So I'm trying to keep cautiously, trying to avoid it popping and spilling. Be careful with your lab stuff. Note I'm wearing a lab coat. I'm going to wear safety glasses. If you want to be extra cautious, I would suggest to wear safety gloves. We are dealing with strong acids, strong bases, somewhat toxic chemicals. So, And I do not want to boil this down to dryness. I want to leave it largely as still liquid. So liquid with some solid. Okay, so I'm going to go ahead and have that be done. Our next step is we are going to carefully add this to a test tube. We're going to pour this into a test tube. We're going to decant. So when it says to decant, we're going to pour it very carefully. We're going to try to transfer this to a test tube. We're going to centrifuge this, and so that the solid will be stuck at the bottom of the tube and the liquid would be on the top portion. We're going to carefully, it's still a little warm, let that cool for a minute. I'll check back with you in a minute or two once that's cooled down a little bit. While I have given it a minute or so, I'm going to go ahead and continue moving. So, while it may be hot, you may want to grab one of these little mitts to help you pour. So I'm going to carefully pour in all of this into there. Notice that there it goes. So I will need a test tube that is about equally full of water to balance this as I centrifuge. So grab my water. I want it to be slightly more full of water, as this weighs a little bit more. Ideally, they should weigh similar. Okay. We're going to move into the centrifuge room. Here we have the centrifuge. So you'll notice there is 8 different areas. You may not want to place them right next to each other, but you can place them every other one at least. But the key here is to never run them unbalanced. So you must always have a tube opposite. If you have 3 tubes, you have a blank one. If you have 2 tubes, you don't need a blank one. 1 tube, you need a blank one. You will always have an even number of tubes in the centrifuge. So we're going to close this. Notice that it's off. When we flip this, it'll be on, but it won't start running, at least this one, until you turn up the timer. I think this one you need to turn up at least 5 minutes to let it go. Then it will start. You can already kind of hear it speeding up. You want to make sure that as it speeds up, it does not appear to, some small vibrations is okay, but we don't want it wobbling to the point where we can see it like moving across the bench top or anything like that, because this is going to be spin up to a decent rate. And after the 5 minutes, it will automatically turn itself off and start to slow down. We should not try to open this while it's running. We shouldn't even try to open it as it is spinning down. We really shouldn't, but anyway, we will come back in and check back in on this when it's finished. You can sit down and maybe start thinking about the next step while we're letting this go. Now, we have 2 centrifuges. Do your best to give people ample time to join you at the centrifuge. Try not to use the centrifuge for 1 tube, because if there's 1 tube in each centrifuge, each group is going to have a rough go at it. Now, it is just finished. You hear it go bing. Well, you may have missed it because I may have started a second too late. I'm going to go ahead and turn it off for now. slowly spinning down. I'll show you what it looks like. There, I would not necessarily suggest you doing this. As you see, it's still spinning rather fast. We'll take a minute before this fully ceases to spin. Or at least slows down to a reasonable speed. Note, trying to slow this down, especially slow it down too quickly, could disturb your solution and cause the solid we just worked on getting to the bottom. It could cause that to then in turn dissolve, because right now it's kind of stuck to the bottom. So it's like if it jerks it too rapidly, it could boom, pop off the side, just like a carnival ride. It's slowing down rather quickly. You can see the marks on some of these where people have been rather impatient when it comes to trying to slow this down. It is already very, very rapidly slowed down. We don't really want to be sticking things in there. We don't want to catch, pull. We don't want to also make sure we do not break our test tubes. We want to make sure our test tubes are in good condition. I've checked all my test tubes to make sure they're in good condition before putting them in there. But there's our water. We can leave that in there for now. See right here, there's our solid and there's our liquid. Move this back to our area here. Now, the solid is referred to as the precipitate. The liquid is referred to as the supernatant. We must always be careful that we know what we wish to keep and what we wish to trash. In this first centrifugation, we wish to keep both the surfactant and the supernatant. So I'm going to carefully decant the supernatant into another test tube, and we're going to save that, and we're going to save the solid. We're going to carefully pour just the liquid. Trying to keep it just the liquid because the solid is one, maybe two metals, and the liquid is another. Now, mind you, we are not going for perfection. We're not going for completion. We are going for a complete separation, though. So there is not, this solid is not dry. It still has some small amount of the supernatant. However, we notice this is completely without solid. So we're going to save that for testing later. However, so the liquid should contain chromium and aluminum. And our solid should be containing the nickel and the iron. So, now that we have separated some amount of chromium and aluminum from the majority, it's the majority of the chromium and the aluminum from the iron and the nickel, the next step is to carefully wash and remove the rest of the chromium and the aluminum. So it says to add about 4 mils of deionized water to this, and then we're going to add about 20 drops of the base, so we're going to up that to maybe 30. We're just making sure it is incredibly basic. So please note, the iron and the nickel did not precipitated in the base. The other stuff didn't. So 1, 2, 3, 4, 5. 6, 7, 9, 10, 13, 14, 15, 18, 19. 2, 3, 4, 28, 29, 30. So the idea here is that by washing this, we're going to stir this vigorously. By washing this and stirring this vigorously, we are getting rid of any trace of the chromium or the aluminum. We do not want the false positive of the chromium or the aluminum. So we are going to centrifuge this again. However, this centrifugation, we are going to keep the solid, but we are going to junk the liquid, because we already got the majority of the liquid. So basically we got 95% of what we wanted. This washing step is to get the remaining 5% out, and that 5% we're going to allow to go into the trash. The solid is what we want. So please make sure we know what we're keeping. The next step is I'm going to centrifuge this. But while that is centrifuging, we can move on to the liquid, the aluminum and chromium. We will come back to this when this is done. But in the meantime, we can centrifuge this. And if you're doing this smart, you can time this so there's not a lot of dead time. So I've got to make sure the liquids are about the same. About the same. Okay, that in mind. Start this for another 5 minutes. As I said, you're running this. You don't have to run this right away. It's just we cannot deal with the solid until we've removed all the liquid. So we'll come back to that later. So with that in mind, the next step is to separate the aluminum from the chromium. We are going to slowly add vinegar to our supernatant until it's acidic. So we're going to have to test that. So we need a stirring rod to do that. So we need blue litmus paper. Blue litmus paper turns red in the presence of acid. Grab something from there. I do have the right concentration. So 6 molar acetic acid means it's very acidic. We don't want it way too acidic, but we do want it acidic. So I'm going to add going to try that. Well, that's 6 drops. I'm going to stir this a little bit and test this to see how it is. We want it just barely acidic, so that, nope. Want it just barely acidic so that when we make it basic, one thing precipitates, the other thing does not. Because we just want it barely basic as opposed to largely basic. So 3. Try that. So another 5. Nope. So we add a lot of base to these, so it might take a little bit. So, 2, 4, 5. So I'm keep on adding, keep on swirling, keep on testing on, and our litmus paper, which is blue, should eventually turn red in the presence of acid. It's still very much so blue, so I'm going to grab another litmus paper. Keep going. So, as I said, the goal here is to get it so we want the aluminum to precipitate out. 3, 4, 5. But to do that, we need just the right amount of hydroxide. But we don't want too much hydroxide, too much ammonia. So that's why we are carefully making it acidic and then trying to go back to base. I'm up to something like 15, if not 20. If I had a pH meter and I wanted to test it, I would be better know what it is. 3, 4, 5. Keep going, because if it's not acidic yet, well, just keep going. Okay, so it is acidic. You can tell because you can see right here, the blue litmus paper has turned red. So we have now made this acidic. The next step is to take this back to basics. We're going to slowly add 6 molar ammonia, 1 drop at a time, until it is basic. At this point, then we're going to add 20 more drops. So because it's half that concentration, I would suggest 40 more drops. But so we want the base to only come from ammonium hydroxide and not from sodium hydroxide. So I'm going to need red litmus paper. Going to find that. Now, red litmus paper is naturally red. And as I add the ammonium hydroxide, 1 drop at a time, and stir that, it will eventually go back to blue. I'll go ahead and add it, maybe 2 drops. 1, 2. Give it a stir. Because keep in mind, ideally, as long as we didn't over add our acetic acid, it should be mildly, okay, so it's already got it back. I already got it back where, look, it has turned blue. So the next step is to add 20 drops, well, 40 drops of our ammonium hydroxide. So, yeah. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 19, 20. 36. I need just a pinch more. 36. Almost there. I might be done, but I'm going to get 40 drops. So 37, 38, 39. So after 40 drops, we should be starting to see a gelatinous aluminum solid. Maybe we don't see, oh, you can't really see it when it's stationary, but when I give it a swirl, you can really see it jiggling around. So our next step is to remove this aluminum solid. This aluminum solid is probably the hardest to see. This could be clear or pale yellow solid. We're going to stir this for about a minute, allow this to reach equilibrium, and then we're going to centrifuge this. So in the meantime, the one centrifuge has actually finished. So I'm going to give this a good stir, make sure it's fully mixed. We want to make sure it's reaching equilibrium. So the idea is that the aluminum hydroxide, we get a aluminum trihydroxide solid, but we don't get anything else. So note, I had skipped the end of step 6 and step 7 to move on to step 8 so that I can let that centrifuge. I'm going to switch these and go right back where I was in step 6. So the next step is to take this and centrifuge. Ideally, this should be forming solid as we speak. Oh, good. Our centrifuge has stopped on its own. Take out our solid. That's about the right. There we go. At least when you're working by yourself, you can have a very good time. You can make very good time. Now, okay. So the end of step 6 was to carefully, I'm going to use that as my waste, carefully pour out only the liquid from this solid tube. Notice the liquid is clear and not the pale yellow that it was before. I'm going to carefully just pour out that liquid and not the solid. I want to keep the solid behind. So essentially that contains any trace amounts of chromium and aluminum, but none or very little of our iron and nickel. So to this guy, this is the washed solid, we are going to add 2 mils of nitric acid. So 2 mils of concentrated nitric acid. Should be the right concentration, and we can move right along. As I said, if you're paying close attention, you do not have to follow any particular order. You can jump around while this is centrifuging and do this and do that. So I skipped I'm not doing step 11, which step 11 involves the separation of the aluminum and the chromium. So the next step is to add about 2 mils of nitric acid to this. The idea is that this should help redissolve it. outside, so we can further react and understand what's going on. So add about 2 mils of that, save the contents. I'm going to go ahead and give that a good stir. So, if they're saying, if it is not completely dissolved, give it a good stir. If we have to, use a hot water bath, but we want, ideally, this to be completely dissolved. Don't want any solid left behind. I'm going to go ahead and set up a hot water bath. Our goal is to get this to fully dissolve. Now it might still be brown in color, but we want it to be dissolved. So a little bit of heat. And we can already tell with a little bit of heat, it is already becoming at least translucent, even if it's not colorless. So we can definitely tell there is some dissolving that is happening as we're heating up this hot water bath. So the idea is that this will react better once that's fully dissolved. So I'm trying not to add too much because we're going to make this basic again with ammonia. We use a lot of ammonia, because ammonia makes some interesting complexes as opposed to hydroxide, not nearly as much. Grab on this testing clamp so I can grab that out of there without burning myself. It's already. Okay, I'm going to put that back down real quick. Don't want to overheat this. I can already tell. Back to a bluish, yellowish solution. So I'm going to let that cool down. Actually, well, I think that's done. So that is essentially step 14. I will come back to that since my aluminum one is just about done. I'm going to go fetch that from the centrifuge. I will turn in a minute. This is the byproduct of my aluminum chromium centrifugation. Well, that doesn't look any different. If we look at the very bottom, we see that little smudge. That smudge is the aluminum ammonia, the aluminum hydroxide solid. That little smudge is your aluminum hydroxide solid. So we're turning to step 10. We have centrifuged this. We're going to pour the supernatant into another test tube. Okay. We're going So we're going to pour the supernatant into another test tube, and we're going to once again wash and centrifuge that solid. So we're trying to get just the liquid. So we're going to say we got just the liquid, put that aside. That is our chromium. To this guy, our aluminum, we are going to add 6 mils of deionized water. We're going to place the solid in the water in a hot water bath for about 2 minutes, stirring occasionally. So we're going to go back to that hot water bath we have. And we're going to stir that about 2 minutes. Now, and then we're going to centrifuge and once again recollect. So I'm going to let that stir. Now, I'm going to skip on ahead because while that's heating, I can immediately test this for chromium. So please note, I'm jumping ahead to step 13. To this, I need to add 12 drops of barium chloride. If I add barium chloride and this contains chromium, we should get a pale yellow solid barium chromate. So far that is 10 drops. I think we're safe to say that we have barium chromate. It may not be as pale yellow as I would like, but that is very much so barium chromate. Seems to suggest, yes, we do have our barium chromate. So this is done. Now, in the presence of iron and the other stuff, no, it should not form the solid. So I'm going to go back and stir that a little bit, see how we're doing. Back and check on that in a minute. I'm going to stir this one more time and then I'm going to set this up to centrifuge. So this is the end of step 11. Fine. So we're going to centrifuge this guy down. The idea is that we're trying to wash away any chromate that maybe got stuck on the aluminum, so that we can be sure this solid is as much aluminum as we can. So I'll be right back after I start the centrifuge. So as we are waiting for the aluminum to finish, we are going to move on to step 15. So we have completely dissolved our iron. We now need to make it basic again. Though, slowly add this until it's basic. You should see a red-brown precipitate as it turns basic. It will not, the solid will be a dead giveaway. I'm starting to see some of that maybe forming. Let's 2 more drops, and then I'll give it a stir. So check the acidity. Nope, still very acidic. So, oh, for God's sake. Well, it's getting there. But I need to keep adding ammonia until it is basic. Notice we're going from acid to base because certain things will dissolve in certain pHs. Certain things will form unique complexes. Keep going. Let's give it a... I definitely see some red brown precipitate right there. Make sure it's not going to dissolve. Is it basic? Not really. It's still very much so red. It's not the clear red turned blue or blue turned red. So it's a red stays red in acid, or reddish, and blue stays blue in base. So keep going, keep going. Give it another stir, because I'm really starting to see that the solid stops going away. Gonna be more of a hint. Nope, still not really blue per se. One. Okay. Looks like the solid may be finally sticking around. I don't know. Let's see. No, I'm going to need another pH strip. I'm going to keep going. Ideally, you want it so it turns blue and stays good. As I said, if you plan this right, you can do this with the minimum amount of wastage of time. Though I will have to prep plenty of containers so that we don't have to share. Okay, yeah. So you see there, the solid has definitely firmly stuck around. After I stir this, it is no longer disappearing. That is because it is because we're starting to lose our acidity. Still not enough that it's turning basic all the way, but let's try a couple more drops. So, mind you, there we go. We have base. You can tell absolutely because you can see here, this is where I put the first drop. Can't see it. Second drop, blue. So it is now basic. To finish this step off, we need to. So we finish that step off. We turned it basic. Now we're adding an additional bunch of ammonia. So once again, it says 20 drops of 6 molar ammonia. So in my case, with 3 molar ammonia to work with, I'm going to drop 40 drops. 1, 2, 6, 7, 8. That's 34. I'm going to add 6 more. The idea here is that while the nickel might have precipitated with a little bit of ammonia, it will fully redissolve as it forms a ionic complex. So we'll have a solid and aqueous. A solid and aqueous metal. We have a solid nickel hydroxide and an aqueous nickel, a solid iron hydroxide and a aqueous nickel hexa ammonia. So now we're going to centrifuge that and separate it. Centrifuge that and separate it. So my aluminum has just finished. I'm going to pull that out and replace it with this guy. I will be back in a minute. Now please note, you'll note my aluminum, still that little smudge back on the bottom. I am jumping back from there to the end of step 11. So step 11, we have centrifuged this, and we're going to carefully pour my supernatant into the waste. So I'm keeping the aluminum smudge down there. That's usually a pretty dead giveaway. If you have any smudge down there, that's probably a dead giveaway. You have aluminum. But so, okay, we're going to drop 4 drops of our acetic acid into there and 6 mils of water to dissolve that. Then we're going to do catechol violet. So the reason this guy exists here is because it is essentially basic. It's very basic. So 4 drops of that. Should redissolve that, and 6 mils of water should help that redissolve. Note, I'm going to go ahead and stir that real good to try to make sure it's all dissolved. I want to make sure all my aluminum is dissolved. No longer any flakes floating around. Okay, so we now have that fully redissolved. We are going to add catechol violet. The idea of catechol violet, it should turn blue. So we're adding 4 drops of catechol violet, and this is what we should see. Okay. Stir. And it takes a little bit of time. The solution should be blue, bluish at least. It's a little hard to tell. But let's look at, I want to look at what does catechol violet look like in just water and acetic acid. Make sure it's not just the, so this is catechol violet by itself. catechol violet with the water, and just to make sure it's not the acetic acid that is make that color. So please note, it may not look super blue, but compare this to catechol violet by itself. You'll notice an amber yellow versus here's our blue aluminum. So we have confirmed chromium, we have confirmed aluminum, and we're currently separating out the iron and the nickel. We are currently centrifuging this, which is the end of step 17. So, end of step 17, once we separate that into two different test tubes, we'll be ready. So I'll check back with you at that point. The result of my last centrifuge is we have a brown solid on bottom and clear liquid on top. I'm going to pour the supernatant into the last test tube. We're not going to bother to rinse either of them or rinse again. So this guy should be our nickel. If we've done this right, 8 drops of dimethylglyoxome will produce a rose red complex. So we're going to save that, and we're going to convert rose red precipitate. You can definitely see the red particles precipitating down. It's not all red all the way through, it's red solid. You can see as I shake it, kind of see the red particles moving. And that is our nickel. Confirmation of our nickel complex. Now for the iron. Yes, it's probably iron. There's a good chance it's iron. But to confirm, we are doing a confirmation test. We're adding 12 drops of concentrated HCl. And then some water to help dissolve this. 12 drops. Help redissolve this, as will the 4 mils of deionized water. We were trying to get this to redissolve, so that's pure iron. Stir well until this is redissolved. The only reason this is a solid in the first place is because it was basic. So as we added this acid, it went back to acidic, and so the iron redissolved. It's kind of a little murky, but so in the last step we are going to add 4 drops of thiocyanate. We've already done this before. What happens when we add thiocyanate to our iron? It should form a nice red complex.